everybody, I'm Josh. I was a computer science examiner, head of computer science, and also I run a tutoring business where I've helped thousands of students to get better grades in computer science related courses. Now, today's lesson, I've really tried to condense as much information as possible. This is going to be a slightly longer lesson, but we've all got, if you're in OCR and Cambridge International, paper 2 exams coming right up. AQA, sorry about this, but this isn't going to be relevant until next year. It's still going to be relevant for paper 1 for AQA because it's the programming paper. Now, what I've done is I've condensed the information down into all of the keywords that could potentially come up. So, high frequency things which I see as an examiner, which come up all the time. And then all you got to do is write the questions down, write the answers down, and then just go through these lots and lots of times. If you've only got a few days until your exam, you can still make huge amounts of progress on this. The way I see it is paper 2, there's about 30-ish% that up for grabs that you can just by learning keywords. Learning keywords is the shortest way the shortest journey that you can take to improving your grade. Learning programming, which I have got videos on as well, so please do check those out. That's going to be the easiest way. Learning a definition is much easier than learning how to program. So this is every single keyword that I can think that can come up. And Cambridge International, I'll be talking about certain things which aren't going to be relevant to your course. So just ignore those. But we'll go with these ones. And then all you got to do, write the descriptions or write the questions that could come up, write the answers, and just keep going through flashcards until you can do them. Okay? Right, so algorithm keywords is the first one, where what we're going to do is you could get a question which is describe what abstraction is, ignoring unnecessary details and focusing on the important parts of a problem. Decomposition, breaking a large problem down into smaller problems. Also, then you've got algorithmic thinking, which is breaking down a problem into steps to solve the problem. So an algorithm is a set of steps to solve any problem. Flowchart symbols. With flowcharts, essentially what it's going to be is you've got so on there, what you've got is you've got the different symbols. You've got input, process, decision, subprogram, and terminal. I'm not going to go through any questions such as like flowchart, how to solve a flowchart problem. There is a video on that, but you could get a question where it simply asks you what is the input output symbol, and you just put that in. If you just remember, it's a parallelogram because that's the one which everyone mixes up with the process, the rectangle. Just make sure you know those. You can maybe be able to grab yourself a couple of marks. Syntax and logic errors. Definition for syntax error is it doesn't follow the grammatical rules of the programming language. So, for example, if you missed out T, and also actually we've put a capital P in that one as well, so there's 2 errors in that. It's going to be instead of print for Python. Logical errors, it works syntactically but doesn't have the intended output. So what they might do as well on these kind of questions is tell you to look at a code and say, where are the errors happening here? These are just some, it might not exactly be this, but this gives you some places to look. Put the greater than or less than signs the wrong way round. Missed out an equal to, or put it the other way round and missed out the equal to. If they're creating a total, are they storing the variables in the correct places? So check the variables so that's actually going to output the correct thing. As I said, are we outputting the correct value? The last one, which is a little bit more vague, is code missing from this, which is going to mean that the code outputs the correct value or, does what it intends to do. The searches now, Cambridge International, you only need to know the linear search, so you can skip over the binary search. For AQA and OCR, you need to know the binary search. So a binary search is the idea of going in the middle value, removing half of the list, and then repeating that process until you find it. So let's have a look at how a binary search works. So say we're looking for Mo, we're going to go to Lara. And then what we do is we ask the question, is Mo Lara? No, so we compare it. And then we say, is L less than or greater than M in the alphabet? And then what we do is because Lara is less than Mo in the alphabet, we delete everything before it because the list is ordered. For a binary search to work, the list has to be ordered. So that removes half the list. And then we go and find the next middle, which is Pam. Ask, is Mo Pam? No. And then what we're going to do is remove everything from so then we ask, is it greater than or less than? PAM is greater than, so what we do is remove everything after it, and then we find mo. Okay, so it's this idea that it's going to take a lot less time to use a binary search, because you go through each item in it, and it removes half at a time, so it's much quicker than what's a linear search, which we're going to have a look at. So the two sorts of questions that they're going to do and going to ask you on is it's going to ask you, it could ask you to perform a binary search on it, so just give you a list of items and talk through the steps of how a binary search works. It could also ask you to describe how a binary search works. So what I've done is I remember marking one of these, this exact question. So what I've done is I've copied this answer exactly as it was on the mark screen. It has to be a sorted list, so that's the first bullet point. What it does is it works out the middle value by adding 1 to the number of values and then dividing by 2. On this, it will always round down. So if it gives you 7.5 as the positional value, it's going to round down to 7. It will then compare the value they are looking for with this. If it's found the value, it stops. Then if not, it discards the values either lower or above based on the alphabet, and then moves and then repeats this process until it either finds it or told it's not in the list. A linear search, this is where you would use this on an unorganized list. So a linear search starts at the first item, compares it with the value you're looking for. If it is the value it outputs is in list. If it isn't, it moves on to the next one and repeats this and moves through the list sequentially until it gets to the end where it will output not in list. Really important that you say that it starts with the first value. That was I remember when I was marking a paper, this was somewhere where lots of people messed up on. This is also the algorithm for a linear search. It's said in the OCR specification that students had to know the algorithm of how the linear search works. So it might be worth just making a note of this. Cambridge International and AQA, again, it's not going to hurt to know this because it's just in a programming sense how we can actually code a linear search. So you've got a list, which that will change obviously based on the situation. This one here, they ask for you to enter in an item, and then you've got for I equals 0 to the length of the numbers minus 1. So just before you get to the end, because the item starts at 0. Remember, arrays, the first position is 0, so we need to do 1 less because 0, 1, 2, 3, 4, 5, 6, 7, and then we're going to have to take 1 off the end because we start from 0. If numbers I, so the position 0, so if position 0 is the one we're looking for, output the search item is found. If not, just keep repeating that process until we get to the end of the list. Okay. The comparison of these searches is the follow-on question from this. So what you generally want to say is if it gives you a situation and asks you which search you should use, an ordered list is an ordered large list. You would always use binary search. Linear list will take much longer. Quite a sort of more advanced point on this is to work out the number of searches it would take in a binary search to find a value. What you have to do is 2 to the power n, so 2 to the power, and then of the items in the list. So let me give you an example. If it's 16 items, I ask the question, how many times do I times 2 by itself to give me 16? So it's 2 to the power 4 because I times 2 by itself 4 times. 2 times 2 times 2 times 2 gives me 16. I then add on 1, so the maximum number of searches would be 5. If it was for 64, what I would do is how many times do I have to times 2 by itself to give me 64? So that's going to be 6. And then I have to add 1 onto that. So the maximum searches in a list of 64 items is a binary search would take a maximum of 7. Can get it before that, but it might ask for the maximum number of searches. In a linear search, obviously, it could take the number of items in the list. So if you've got 1 million items, it could take 1 million searches. So it's a lot slower. In some situations, it's not going to be, you wouldn't be able to do a binary search because the list is unordered. And if it's generally a smaller list as well, it might just make sense to do a linear search. But the big thing is if it's unordered, you have to use a linear search. Now, A bubble sort. How a bubble sort works is used. So sorting, as we've just talked about the searches. Sometimes it's going to make sense to sort the items and then search them. So with a bubble sort, this is the most inefficient form of search. And what you have to do is, the question you could get on this is getting you to describe a bubble sort. So the description on here, just copy this down onto a flashcard. Start with the leftmost item. Compare the item with the one next to it. If the one next to it is less, swap the items. Repeat for all other items. At the end of one pass through the list, the largest item is at the end of the list, and then repeat the process until item stored. So let's have a look at how it works with this one. 9 is, so we ask, is 9 bigger than 5? Yes, so we swap those over. Is 9 bigger than 4? Yes. Is 9 bigger than 15? No. So that's then where some people will go back to the start. Do not go back to the start. What you are going to do then is you're going to take 15, and then you say, is 15 bigger than 3? Yes. Swap those over. 15 bigger than 8? Yes. Is 15 bigger than 11? Yes. Is 15 bigger than 2? Yes. At the end of the first pass, so that's what's called a pass, you should have the biggest item sorted on there. And then, as you can see, as you go through the passes, you've got a second pass, the second biggest item is sorted, and then the third, fourth, fifth, and so on until the end. And also, you can see by this, it is a very inefficient way of sorting because there is lots and lots of sorting. Okay, that's for all examples. You do have to know how that works. Now, this is just for the OCR specification, so if you're AQA or Cambridge International, ignore this. But essentially what we've got here is the insertion sort. Okay, so the insertion sort is just a deck of cards. And what you are going to do is you take why it's like a deck of cards is because you essentially take the item and then you just sort it. So 9 is the first item, so we put that in position, which is by itself, so it's there. Then we take 5, put that in position. 4, put that in position. 15, put that in position, and so on until we get to the end of the list. You just insert it into the correct position. And that has taken, in comparison to bubble sort, where it's much more efficient, it's 8 items and it's taken 8 sorts to put that into position. Now, with the final one, with merge sort, is what every time I've seen a question come up like this, it just asks you to describe the last part of the process, or just talking about how a merge sort works. So you split each of the items up, like so, and then just go from there and describing what's going on. You pair them up. Key distinction here, I know that this might seem like a weird distinction to make, but I just remember quite a lot of people didn't get any marks, and they probably would have thought they got marks on this, is they talked about how it pairs them together and then swaps them. But can you see it pairs them and swaps them at the same time? So just make sure that you make that distinction really clear, because you won't get the marks if you say it's a 2-stage process as opposed to 1. And then they're paired up again, where they're all paired and sorted, and then paired and sorted at the end there. Now, comparison, bubble sort is the least efficient sort. Insertion sort so 8 items will take 8 sorts. Merge sort, we saw that once everything is individualized, 8 items, it took us 3 sorts to do that. So very, very efficient. So merge is the fastest, insertion next, bubble sort least efficient. Now, moving on to the programming keywords that I can think of. Variables, label which points to a location in memory. Whilst the program is running, it can change. So like num1 is equal to int input. That's going to change based on the program. Maybe you add some values to it. A constant, label which points to a location in memory. Whilst the program is running, it cannot change. So the only difference there being that it cannot change. So use the definitions. I always try and make it as easy as possible for you to remember things, so that you only need to remember one definition and change that keyword there. Sequencing, program executes one line after each other. So the common question on this one is either define it just executes one line after each other, or they'll show you some code and say where's sequencing happening. So you look at the code, and it's just where I kind of think of it as an absence of if statements and loops and everything going on there. Okay. Selection, where the code makes a decision, if statements, elifs, else. Iteration, the code repeats itself, while and for. Data types, int is where you've got whole numbers, real, decimal numbers, boolean, true or false, char, single character, string is a collection of characters. That's where it actually gets its name. So it's actually a string of characters. That's why it's called a string, but I've put a collection just to help distinguish between it. And it can have numbers in there as long as it's got speech marks around it. Casting, it just asks for the definition on this one, where you change a data type from one into another. So when you've been using like num equals int input, the int there is something called casting. And essentially what it is where we're changing the preset value, which is a string, into an integer. As I said, very quickly, I'm just trying to go over and give you as much ability in a short period of time to get marks. So I'm not going to go fully into SQL. I'll try and get out a lesson on that about SQL. But if it asks you to write an SQL query, what you're going to do is select from where ordered by. Select is the field names, from the table names. If you just can work out from the question what you're doing on that, that's 2 marks there. Where is like the if statement, and then order by is the is how you want it to be ordered. So if you wanted to order it in so it's going alphabetically, that's where you would put surname in there. Okay, so you'd put surname, and then it would order it alphabetically by their surname. If you wanted it to go in the reverse order, you put something called DESC, so descending, that is. To make it go in ascending order, you don't need to put anything though, it just automatically does that. Functions and procedures. They just sometimes say, what's the difference between a function and a procedure? Function returns a value, a procedure does not. How many parameters does a function have? So they'll show you one here. We can see there's 2 because you've got num1 and num2. Local and global variables. A local variable is a variable which can only be used in a specific subroutine. A global variable is used across the whole program. Generally, what they follow that up by saying is then which is better to use and why. So you're going to use local variables because you can reuse the code more easily, because that doesn't mean that you've got global variables which are interacting with the whole program, so you can just take out subroutines and use them. It's also more easier to debug because if you've got global variables, they interact with lots of different areas of the program. Local variables, you know, it's if there's an error, you know it's quarantined to a specific area, and that means it's going to be a lot easier to locate it. Now, I would also, on Cambridge International, there is a lot, and actually AQA, they talk about the importance of using structured programming and why do we use functions and procedures. So these, I always say, when in doubt, talk about how you can reuse the code. So structured programming, you can reuse the code much more easily. And also, it's much more easy to debug. The other things as well on those points that I would say is that programmers can work on you can development time is a lot less because programmers can work on different parts of the program at the same time if you're using functions and structured programming language. On to the defensive design. So generally, defensive design means like how can you make a program that's going to account for users' errors. So you've got you essentially getting the user to verify their details by doing double entries. So if it asks you about verification is where you're trying to get the data to be the same as the original. So in that would be double entries. Double entries is a form of verification. You've also got validation, which is trying to make the data reasonable that you're entering in there. So that's things like range checks, length checks, presence checks, where you're trying to make sure the data is reasonable. So here I've talked about anticipating errors. If the program requires a password of 8 letters to put a length check on the password. Okay. Maintainable code, how to make the code more maintainable. It just means how is it that you could make the code more easy for other people to pick up and use. Writing comments explaining what the code does, use subroutines, give appropriate variable names. They might ask you to actually give an example. So, if it's got like var1 and it's talking about averages, just call it average or total or whatever it is. The other one, which I actually missed out, is indentation. Okay. Definitely spelled that wrong. Dentation on there. Okay, so we've got indentation, which is just, it's indented in the part of the code. So it just indents the code and it shows which part of the code it belongs to. Testing. On here, we've got final and iterative, where you've got so testing the code when the code has been completed, and iterative is testing the program whilst the project is going on. Test data. For a program that takes inputs from 1 to 100. So normal testing is something that should be accepted. Okay, so you might just enter in 50 for that. Boundary. Now on OCR, this means that you would test 1 and 100, but it's on the edge. In Cambridge International, just double check the specification, but I believe there is actually a slight difference on that, where you would also be able to include the 0 and 101. So it's on the edge on that one there, because it's also called extreme on Cambridge International, which to me extreme would be like a really, they've all got different definitions. So I'm just saying check for your specific specification. And then invalid is just something wrong, -1 or just a completely wrong statement in there. Logic gates, the and, or, and not. Key things on that, make sure you know your and, or, and not tables. Cambridge International, you need to know the XOR gate as well. So look that one up. Make sure that you've got so know how to draw it, and also you've got the truth table on it. Big thing on the not gate is please make sure that you remember to put this little circle on the end of it. Either you don't get the marks. High level and low level languages. The keywords on this one is describe high level language. Looks like English, maths, programming language like Python are high level. It uses a compiler and interpreter to translate to machine code. Low level languages uses mnemonics to code. Assembly language is a low level language. Uses an assembler to convert into machine code. Describe the machine code, the zeros and ones that the computer uses to write the code. So yeah, it's just the zeros and ones. Both of these do get translated into machine code. I did see, I was actually just working with a student, and I saw that they was talking about the advantages of high-level languages and assembly so the advantages of each of those. So high-level, easier for humans to read, HHL, high-level languages, so Python. Easier to understand, easier to learn for human beings. Assembly language, easier for the computer to process, so it doesn't have to do as much processing to take it from assembly language into machine code. And it also can control individual pieces of hardware, which is why it's sometimes used in embedded systems quite a lot. Last two slides, so I'll quickly go through these. Translators, they could ask you to talk about an interpreter and a compiler. The key things are, if they ask you to discuss situations where you would use them. Interpreter, you translate one line at a time, and it reports the error on the line it finds it on. Sorry about the spelling mistakes. As you can see, I was trying to get this one out as quick as possible because I know we've got exams coming up in literally a couple of days, so I was trying to get all of the information for you. Compiler translates all code at once and gives an error report at the end, much faster than interpreter, and gives an executable file at the end. It depends on the processor that you can't run an executable file that was made specifically for Macs on a Windows computer. As you can imagine, software companies, when they're making their games or applications, whatever it is, they're going to use a compiler because that keeps people dependent upon the machine or the piece of hardware that they're using. So that's why Xbox or Microsoft won't let you run their games on PlayStation. I mean, there's a bit of crossover on some of the games, but generally what they're going to do is they're going to keep things specific to their hardware because they want you to pay for it, which then in turn is them making more money. Interpreters, it doesn't matter so much about that, and that's where you've got the open source community, but that's something else. We're not going to go into that now because that's extra information that you don't need. Finally, last thing is the integrated development environment. So the integrated development environment is essentially what you use to code and the errors that can be uncovered on these. Okay, so specific to this is they would ask you what tools could you use on the IDE to fix syntax errors? So syntax coloring, when it changed the print changes color, that signifies that you've done it correctly. Auto completion, so it auto completes keywords. The other thing is they could ask you for logic errors. Breakpoints, it stops at certain parts of the code, which then means that you can check and see if it's working as it should. Variable watch windows is where you can actually watch a variable throughout the program to make sure it's doing as correctly. So anyway, that is everything. As I said, high frequency stuff that comes up. If you do that, make flashcards and all of those. I tried to get that out as quick as possible, so I do apologize for any spelling mistakes or anything, but I hope that's useful, people, and best of luck if you've got your exams coming up very shortly.